We're going to continue talking about slope in this lesson. So far we've talked about slope when we look at a table. We've looked at slope when we look at a graph. We can also find the slope simply between 2 points. So I'm going to do things slightly out of order just so you can visualize this for a second. Let's just scooch down to this example 1 here for a second and take a look at, we've got these 2 points, ordered pairs. We know ordered pairs are in the form x, y, right? So in fact we can call this x1 and y1, and the reason I do that is because I've got another point, and I could, it's also an xy coordinate, but I could call that x2 and y2, and that way I could differentiate between the two. So we know that points are ordered pairs. If I were to visualize this graph, then I know that the point 2, 1 would be somewhere around here. I'm just ballparking it because I want to be quick. So this is approximately the point 2, 1. And the other point 4, 7 would of course be farther to the right and farther up. So let's say 4, 7 would probably be somewhere around here. So these are just 2 points on a graph, and I could draw a line through them. I don't normally, if I'm going to use what I'm going to teach in today's lesson, but if I draw a line through them, then of course I'd have that line there, and then what we've seen is that we can get the rise, we can get the run, right? This is the change in y, this is the change in x, delta x. Sorry, that's hard to read, but that's what I'm saying for, delta x. Maybe I'll rewrite it. Try to make it a little bit easier to read. I'll write it down here. All right, so if we have 2 points, then we can calculate the slope. We're going to do it without actually drawing the picture, though. So let's go back up to here. We know, just as a reminder, that m stands for slope. And it's the rise over the run, which is the same as the first differences divided by the change in the x values, which I've also said can be written or thought of as delta y over delta x. So change in y over change in x. So as I've illustrated down below, we can really just talk about, we can do it if all we have is 2 points. Really, what's change in y, delta y, is really just the difference between the two y's. So if y1, I'm just going to highlight it on this graph, if y1 was 1, and if y2 was 7, the difference between them, we're going from 1 up to 7. So it's really the difference between these two y values. So y2 minus y1. Right? And in this case, y2 is 7, y1 is 1, so 7 minus 1 is 6. So the change in y is 6. And again, look at the graph. You can see that we're going from 1 on the y-axis up to 7 on the y-axis. So yeah, we've gone up by 6. Likewise, we can do the same thing for the x's, the change in the x. We're going from 2 on the x-axis over to 4 on the x-axis. So what's happening? Well, if we've gone from 2 over to 4, we've gone over left to right by 2. So it's the difference between them, though. I can get it by subtracting. It's x2 minus x1. So again, I can do all of this without the picture part. I've just included the picture so you can visualize it, because we are going to do it without the picture soon. So slope, as we know, is delta y over delta x. So that means that it's going to be delta y is just y2 minus y1, delta x is just x2 minus x1. So we can make up a slope, what I will call a slope formula from now on. And that slope formula is expressed right here. This is a really important formula. You're going to need to memorize it. It's going to come up a lot in future grades. So you might as well just memorize it now. y2 minus y1, x2 minus x1. Say it to yourself as many times as you need to in order to get it clear in your head. All right, so I've already partially done example 1 without using the formula, but if I was to finish it off, m, the slope, is going to be delta y over delta x, which is going to be 6 over 2, which would reduce to 3. So we got the slope of 3. If I was to go back and use the slope formula, however, y2 minus y1 over x2 minus x1, then I could just plug in all those numbers. I've already labeled them, right? And in fact, I'll use all my different colors that I already picked out here. Here they all are. That should say x1 there, that second one. All right, so I've got all these different highlighted colors just to try and make it a bit easier. We got 7 minus 1 over 4 minus 2. And again, I'll just go back and fill in the colors to try and make it easier to see where these come from. And then we just simplify this. 7 minus 1 is 6, 4 minus 2 is 2, and so the whole thing equals 3, which is what I already got up here. Okay, so let's do one without drawing the graph. So the first thing we have to do is we have to, again, identify x1, y1. It always goes xy, and the first one I'll call x1, y1. The second I'll call x2, y2. Let's do it. Let's just plug it into the formula. Now we know we can do it without sketching it. So remember, you have to memorize this formula. Here it is. I've memorized it long ago. And I'll just plug in the different numbers. Now, some of my numbers are negative in this case. That means that I need to plug in that negative number as is. So I'm going to put negative 6 in for y2. There's a minus sign that comes after y2. It's built into the formula. And then I'm going to subtract y1. So that's 5. And then on the bottom, I've got 4. And after that, again, there's a minus sign that's built into the formula. But then x1 is negative 3. So that I got another negative coming up here. So these negative signs can cause some people some problems. So again, let's do a little highlighting. Here I'm highlighting the negative signs that are part of the formula. And I'll do it again here. Those ones I've highlighted in yellow are just part of the formula. The other negative signs are ones that were attached to the coordinates. And then I can simplify. And we go back to just knowing our working with integers. Negative 6 minus 5 means I'm going to go farther down the number line to negative 11. And then 4 minus negative 3, these two negative signs, hopefully you know by now, combine to make a plus. So that's the same as 4 plus 3, and that gives me 7. And as always, I try to reduce, but 11 and 7 are both prime numbers. There's nothing I can do to reduce this any farther. That is my slope. Remember, we've learned that a negative slope means that something goes downward from left to right. Now that I've drawn, or now that I've calculated, let's just draw a really quick picture to confirm that this makes some sort of sense. Actually, let me use a different grid. Let's use one that looks like this. So we'll do it over here. And again, just a quick sketch. So let's start with the first point, negative 3, 5. All right, so if I was to graph that one, negative 3, 5, negative 3 is to the right, so to the left of the axis, positive 5, that's up here. Negative 3, 5, that's that point. And then if I was to graph this point here, that's at 4, negative 6. So that would probably be somewhere around here. And that's this point. And if I were to draw a line between them, wrong pen, let's try again. Draw a line between these. Well, lo and behold, this line goes downward from left to right, which is exactly what we'd expect with a negative slope, right? Negative slope right there. All right, so that's the slope formula. those two examples should be plenty if you understood them. And if you had a little trouble following that, just rewind this video and watch it again, because this part is not hard. You have to be clear on what the parts of the formula stand for, but practice a little bit and it works out fine. There's a few other things we're going to talk about in today's lesson. This is a small thing, collinear. This is not an important thing, so I'll just sort of go over it quickly. In the grand scheme of things, slope formula, very important. Whether things are collinear or not quite as important. Collinear just means on the same line. So if something's collinear, they're all on the same line. So if we want to test if things are collinear, then they must have the same slope. This is the key. Everything on the same line has the same slope, right? Again, let's just look back at a picture I've drawn here. That red line I've drawn has got, there's 2 points you can see on that line, that -3, 5, and that 4, -6. But a line is made up of a whole bunch of points. So I could pick other points that are on the line, and if I just find the slope between any of those points that are on that same line, I'll always come up with the same slope. But if I had a point that was off a line and I connected points together, then they're not going to have the same slope anymore. So without even drawing a picture, we can test to see if things are collinear just by calculating the slope between different sets of points, different pairs of points. And if we keep coming up with the same slope, then that will show that a set of points are collinear. So I won't do any examples of that right now because, again, it's not a big deal, this idea of being collinear, but just, again, if you have a question that comes up with this, just review this. Collinear points will have the same slopes between whatever you decide to calculate the slope between. And one more topic, again, a little bit different again, x and y intercepts. This is just another thing that we can talk about as far as graphing goes. So here's just a way to help us do some graphing. So far we know how to graph it with a table of values. In other words, if you have a table of values, then you get your ordered pairs and then you just graph x, y, connect the dots in a straight line, or a curve if that's the case. We can do it another way as well. But first, I guess, the first example, I'm just scanning it, reminding myself of what it says. I guess the first example is showing how to do it with a table of values. So let's do that. Make a nice straight line for my table of values. All right, so x, y. So here is my equation. Remember, I can choose values of x. Let's just remind you, x values are independent variables. They go in the horizontal axis, and I choose them. So looking at this grid here, maybe I would choose the numbers -2 for my x, -1, 0, 1, 2. Those are all x values that I can see are in the middle of my grid, so why not pick them? Y values, I don't get to choose them. I calculate them by sticking my x values into an equation and then working it out. So for the first one, it would be y is going to equal, from this equation, 2 times x, which I chose to be -2 for this first one, -1. 2 times -2 is -4, then I subtract 1 and I get -5. And then I do it again. 2 times, this time my x value is -1. That's what's right beside it. So everything about the formula stays the same. I just put different x values in. 2 times -1 is -2. Subtract 1, I get -3. As I go through putting different x values in, then obviously I'm going to get different y values popping out. In this case, I get 2 times 1 is +2, minus 1 is 1, 2 times 2 is 4, minus 1 is 3. So these are my y values on the far right. So they're ordered pairs. So here's an ordered pair, -2, -5. Okay, that would be down here. And then I've got -1, -3. That's here. And then 0, -1, and so on. Guess what? These all form a line, so it's pretty easy to graph them. Let's draw my line through there. So that's one way that we already should know about graphing a line if all you've got is equation. But we can do it with x and y intercepts. So an x-intercept is defined as the point where a graph crosses the x-axis. To cross the x-axis basically means to intercept it. That's where the name comes from. And the y-intercept is the exact same thing, except it's where it crosses the y-axis. All right, graph, for my last example then, just to show how this works, graph 2x plus 5y equals 20 using x and y intercepts, and the grid is down below. All right, so what I need to do is I need to find where does a graph cross the x-axis? Where does a graph cross the y-axis? So the way we do it is we let y equal 0 and then solve to get the x-axis. Why do we do that? Because, remember, for ordered pairs, we have x and y values that go together. Look at the x-axis here. I'll just highlight that for a second. Here's the x-axis. It's made up of a whole bunch of points, and they all have different numbers, different x-coordinates, but what they all have in common is that the y value of every one of the points that I've highlighted in yellow is 0. It has to be 0 if it's on the x-axis. So every point on the x-axis has got a y value of 0. That's why I'm going to let y equal 0, then solve, and I'll say solve for x. If I want to find the y-intercept, I'm going to let x equal 0, then solve for y. Likewise, here's my y-axis. The highlighter doesn't work quite as well going up and down, but here we go. There's my y-axis. Again, it's made up of a whole bunch of points. They all have different y values, but what they all have in common is that the x-coordinate of every point on the y-axis is going to equal 0. So I can let x equal 0 if I want to solve to get my y-intercept. So if I'm starting with this equation here, and I want to find the x-intercept, which I'll call x-int for short, what do? I let y equal 0. All right? 2x plus 5 times 0. I'm going to replace that y with a 0 equals 20. Now I've got an equation that I can solve. 5 times 0 is, of course, still 0, so that term, that part of the equation can just disappear. I can divide each side by 2, and what I'm left with is x equals 10. So really what I've got is an ordered pair. The ordered pair is x-coordinate is 10, and I've already let the y-coordinate be 0, so it's the ordered pair 10, 0, which I'll graph right now. That's all the way over here on my graph. So that's my x-intercept. Finding the y-intercept, I do the same thing, except that I'm going to let x equal 0 in this case. So now I've got 2 times 0 plus 5y equals 20. And again, 2 times 0 is just 0, so that disappears. And then I'll divide each side by 5. And the y-intercept equals 4. And again, that can be expressed as an ordered pair. X, y, x comes first. I let x equal 0, so this time the 0 comes first, and the y coordinate is 5. So, 4. 0, 4 is this point here. This is the y-intercept. So these 2 points are on the line 2x plus 5y equals 20, and if I connect these points, I know that the line has to go through there. Let's see, try to ballpark this line. No, I missed. All right, let me count. I guess if I start here, maybe I'm good. There we go. Okay, there's my line. So that's a different way of graphing a line. Again, what have I done here? I've graphed the line 2x plus 5y. That's this line here. So we've covered sort of a variety of different things in this lesson, not all of equal importance. Most important, by far, slope formula. Memorize that, practice that, answer every question you can see that has to do with slope formula. Really get familiar with that. Collinear, that uses a slope formula. It's a way of telling if points are on the same line without graphing it, just by checking the slope. And then x and y intercepts, I'd say that's my medium importance in today's lesson. You do need to know how to do x and y intercepts. You have to understand the concept of them, but again, sort of in between as far as importance goes. So now you should be doing the homework entitled Exploring Slope